Record. All right, so I talked to you about what a relational database was, talked to you about what rows and columns are. A row is also referred to as a record. A column is also referred to as a field. We just had gotten into what a primary key was. All right. Again, a primary key uniquely identifies each record. Sometimes, in order to create a primary key, you need to combine more than one field. If you do that, it's called a composite primary key. That's not that big of a thing. All right. But what you want to do with a database is you want to be able to look up information. All right. So even though you have only one primary key in each table, one or more fields in each table is a primary key, there's other fields, like Keegan mentioned, the social security number, that you want to make sure are unique. You want to make sure that everybody, if you are storing a social security number, you want to make sure that the social security of everyone is unique. That's a unique key, and that you can set it up by a unique key constraint. All right. There's also things that are called indexes, and they work a lot like an index in a book. In other words, if I asked you what SQL was, and you had your book with you and you didn't know, you might go to the index of the book, look up SQL, and see where they say the pages are. You'd pop over to those pages. In much the same way, when you put an index on columns, when you go and ask the database questions, which are known as queries, if you have the field or fields that you're going to be querying the database on, if you set up indexes, you get the answers faster. All right. Again, I'm not saying does this totally make sense, and it may make a little more, it may make a little less after this. This is an example of a database table. If you look in here, you can tell there are 1, 2, 3, 4 fields. And there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 records that we can see. If you do the math, if this is the entire database, if this is the entire table, and let's pretend it is, there are 16 records. Each record has 4 fields. If you do the math, 16 times 4 means there are 64 pieces of data on the screen right now. All right. So with their concepts, a relational database uses tables. Yeah, we talked about that. Records are rows, fields are columns. We talked about that. Primary key, we've talked about that. Indexes, I mentioned to you. All right. Now, when you want to be able to grab 2 different tables and get some information from each table, you have to define what's called a relationship between those tables. There are 3 types of relationships that you can have. All right, I'm going to pop out of this for a second, and I'm going to pop back. Where I was writing stuff. Where is that? Oh, where are you? There we are. All right. The 3 types of relationships that you can have in a database are a 1-to-1 relationship. And I'm going to give you examples of each of these in just a minute. You can have a 1-to-many relationship, and you can have a many-to-many relationship. Now, most people, when they think of these kinds of relationships, and it's not really correct, but most people think of it as 1-to-1. You're like, oh, like one husband for one wife, etc. That's not exactly the way we look at it, but for now, it'll do. Now, the old joke, well, that's except, what is it, if you live in Utah or whatever it is, where states that allow polygamy, where one husband can have many wives or one wife can have many husbands. All right. And we're going to look at examples of all of these. This is the one that's the hardest to handle, many to many, because relational database management systems don't know how to handle many to many relationships. So what you do with a many to many relationship is you break it up into a series of one to many relationships. And again, I'm going to give you better examples of these in just a minute. In an ideal world, you'd like all of your relationships to be one to many. All right. So let's suppose I'm going to give you the same example I gave to you before. And that is, let's suppose I've got first name, I've got last name, I've got address, city, state, zip, and let's just put one more field in here. We'll put in cell phone number. Okay. So let's just assume that we make one humongous table for everyone who has anything to do with Rankin. I don't care if you're a student, if you're a teacher, it doesn't matter. All right. But then we start adding more things. I'm not going to put any more in there, but we start adding more things. Now, this table, instead of having 6 or 7 fields in it, now has 20. So let's assume again that we put in something like this. So I'm going to put in this. I'm going to put in first name. I'm going to put in last name. Oops. I'm going to put in department name. And I'm going to put in salary. All right. So we're breaking this down. These are only people now who work at Rankin. Now, you'll notice we have a first name and we've got a last name for each, but that's not how we want to relate this. We want to come in here and do something like this. The key word that you're going to learn is ID. All right. So I'm going to come in here and I'm going to make what I'm going to call an employee ID. All right. And then I'm going to come into here and I'm going to make an employee ID. And I don't need now the first name. I don't need this anymore. I don't need this anymore. I can grab this and put it here. I can grab this and I can put it here. Okay. So what I'm telling you is if I know the employee's ID, I can grab their first name and last name from this table, and I can grab their department number and their salary from this table. Does the concept make sense to you?
Yes.
Because that's what relational database technology is all about. All right, let's pretend that there are Rankins all over the country. All right, and for the department name, let's say that people screw it up. Some people put it in as IT. Some people put it in as information technology. Some people put it in as infotech. They're all the same department, but people put them in different ways. A real popular one is some people write accounting. Some people write it like this. You get the idea? So we're saying we have the same information, but it's shown in many ways. Not only that, if I've got 1,000 employees, even if they do it right, do I really want to write information technology in there 1,000 times? There's probably a good chance it'll be misspelled. Even if we tell people information technology, that it'll be misspelled at least once. So what do? We come in here and we add a new table. So this I'm going to call table 1. This I'm going to call table 2. So now I come in here and I add table 3. All right. And what I'm going to put in here is a department ID, and a department name. So let's pretend for just a second that Rankin has, I'm just going to show you the data that's going to go in here. Rankin has, number one is information technology. Number two is diesel. Number three is automotive. And number four is electrical. And we're going to assume right now that those are the only four programs that we have. Now what I can do is I can get rid of this and replace it with department ID. And now this is only going to hold a 1, 2, 3, or 4. But if somebody says to me, I want every employee's first name, last name, salary, and department name. Does it make sense to you that that information is in 3 different tables? Does that make sense?
Yeah.
So what I have to do now is what's referred to as join together the 3 tables. And I can do it because I've got a field in common between these two, and I got a field in common between these two. That's what we're going to be doing. All right. And it literally is called a database join when you start to join tables together. So they talk in here about one-to-one relationships. It says the 2 tables shown in figure 17.4. All right. Let's look. This is a one-to-many relationship. Take a quick look. Don't worry about where it says primary key and foreign key. We'll talk about that in a minute. But take a look where at the information. If somebody comes in, this information is some kind of a customer table. So it's got the customer name, the date they bought something, the total of what their bill was, the sales tax to their bill, the total plus their bill, which is or the shipping cost, and then everything added together. So this plus this equals this. Does that make sense?
Yeah.
Then what we want is for each customer, we want to know what they bought. So 41, that invoice were these products right here. And you'll notice they all just bought one of one product, except the last one bought 4 of these products. So if somebody comes in and says, hey, I want XYZ, all right, or they come in and they say, hey, I want to know what the, I want to know for invoice order 45, all right, what was bought. Okay, they can tell the customer, but if they want to know the actual items that were bought, they've got to come in here. And then notice customer 40 or invoice 46, customer 20, they bought 3 different things. See that? All right. So I want to show you how we're able to bring that information together. Now you'll notice that the invoice ID, this table would be called invoices. This one would probably be called line items. All right. And the invoice table, the invoice ID is what's called the primary key. Pretend this invoice ID isn't here. All right. It's possible here. Notice we've got A46V, A46V, A46V. We can't use that because remember, it's a unique record identifier. This can't use that. Most of these are not unique. Most of these are not unique. Most of these are not unique. So what we do is we grab the primary key from this table, we add it to this table, and now we combine these 2 fields together, the invoice ID and the product ID. We combine them together. It's called a composite or a concatenated primary key. That becomes these 2 fields together, the primary key to this table. When we bring the primary key from a parent table, like invoices, to a child table like line items. And if we put the primary key into the child table, it's called a foreign key. Now that was a lot to throw at you, and it might not totally make sense. All right. But again, look at it this way in the example I just gave you. Imagine right here, this was that Rankin table I mentioned, first name, middle initial, last name. And imagine this right here, let's just say, was the department number. Then in here, I'd have the department number that I'd add, and then I would have the department name. So when you have information in a database, typically somebody comes in, some kind of a database person, they come in and decide, do we have so much information that it's got to be put into multiple databases, or can we take our information and put it in just one database? And if we can do that and put it into just one database, how are we going to break up the tables? All right. And that's what the rest of the semester is about. All right. So as the author mentions, the invoice ID column that we brought in from this table into here is called a foreign key because it identifies something in another table. Usually with a foreign key, you've got a one-to-many relationship. In other words, this one invoice can hold 0, 1, or more line items. This one customer has one line item. This customer has 3 line items. This customer has 2 line items. All right. And when you have a relationship like this set up, it's one-to-many. That says for every one record in here, there are 0, 1, or more records in here. That's what a true one-to-many relationship is. And again, I'm not saying, hey, does that totally make sense? Maybe it doesn't make a lot of sense. But over time, you'll have to take my word for it. It'll make sense. All right. So when we do this, we have to start defining how our tables are going to look. All right. So what do we have here? I'm going to look at this. In fact, I'm going to write this down for what I'm going to show you. We're going to probably have one more lecture after this one, but I want to be able to show you. Let's see. There we go. We've got an invoice ID, and that's an int, a customer ID, and that's an int, an invoice date, and that's what's called a date time field, a product total, and that's a money field, sometimes called money, sometimes decimal, sometimes just called a number field, sales tax, which is going to be a decimal or money field, shipping, which is going to be a decimal or a money field, and invoice total, which again is going to be a decimal or a money field. All right. So when you're starting to create the database, what you do is you give every field that you're going to use a name, a type, and whether or not you are going to allow null. You may remember this, you may not from before, but null means unknown. All right. Null means unknown. So none of these are going to allow nulls. Anytime you wanted to allow a null, you just click in here and a checkbox would be put in. The primary key cannot be null since it uniquely identifies each record. Some of the different data types you can use, and they're different depending upon the relational type of relational database management system you're using. All right. So as it says, the data type that's assigned to a column determines the type of information. So since invoice ID is an int, it can only hold whole numbers. Since invoice date is a date time, it can only hold dates. That kind of thing. All right. You can have default values. Again, We don't have it here, but let's assume that we're this is the Rankin bookstore, let's say. And let's say that 99% of the business that they do, all right, is let's say we have a field, we don't have it in here, but it's called sale tax rate. And let's say that 99% of the business that they do is people in Missouri. So we might put a default value in for the sales tax rate. All right. It says when you select a column, its properties are displayed in the properties window. You're going to see that as we get going. Now, what they use in the rest of this book is the MMA database. Okay. And I think you have to realize that Muroc, the author of your book, there's Joel Muroc. I think he's the dad. I don't remember, but he's got two sons, and I think that it's Muroc Associates Books, but I'm not sure if that's what it stands for or not. It's not that big a thing, but they want to create a database. It says they're going to use it for the programming examples throughout the sections. Actually, I think it'll be throughout most of the rest of the book. The purpose of the database is to track invoices for a book publisher. All right, so let's see what we have here. I'll make that a little smaller. Is that big enough you can still see it okay?
Yeah.
All right. So what do we have here? We have 1, 2, 3, 4, 5, 6 tables. Now, I will tell you right now, this database is not designed very well. And what I mean by that is these 3 tables, or I'm sorry, this table with 3 fields in it, it's kind of out on an island. In other words, you cannot directly connect this table to any of the other tables. You see how there's a connection here and here and here and here? This is not inheritance. This just means that there's a field in this table that's also in this table. All right, so it's called state here and it's state code here. It's called what? Customer ID here and here. It's called invoice ID here and here. And it's called product code here and product code here. So we are able to relate these. So if somebody came in and said, what we want is we want a customer's name, we want the date of their invoice, we want the state they come from, all right, the name of the state they come from, we want the quantity that they bought, and we want the unit prices. Let's just say we can grab that information by joining together those 5 tables. And at least conceptually, does what I'm talking about make sense?
Yes.
Okay.
Yeah.
All right. And that's what they're explaining down here. I don't want to sit there and read what they have here, but that's what they're talking about. So how does SQL fit into this? Well, when you want to start getting information, this is the way that you do it. So you come in here and you say something like this: select name, comma, and this is all, just so you know, case insensitive. Everything, even this, you can put it in uppercase, lowercase, or mixed. I tend to, when I write mine, just so you know, because you're going to see me write some SQL in a bit, I take every keyword like select, from, where, and order by, and I capitalize all of those fields or all of those words. Everything else I put in totally lowercase. So this says, I want you to go through your database and your customers table, which we just looked at right here. So it's got customer ID, name, address, city, state, and zip. I want you to go through that table and give me every customer name and city where their state is Washington. Okay, so if we look through there, all these cities that you see right here, every one of them is in Washington. Does that make sense?
Yeah.
And we're ordering it by name, and you can see that's in alphabetic order. If we ordered it instead by city, then it looks like whatever that is, Kennewicken would come first, then Kirkland, then Oregon, or I'm sorry, then this Modula Terrace, then Oregon, then Pullman, etc. So what we're telling it to do is select means give us. That's like, again, that's like a getter that we just went over in our object-oriented stuff that says give us the name and the city. From says where do I want it from? I want it from the customers table. If I put where in there, I'm putting criteria. If I put a where in there, that's saying where, only give me the ones where the state is equal to Washington. If I want everything in a table, if I want to see the whole shoot and match, every single thing that exists in a table, I can type in select asterisk from customers. And if I do that, I get, if I've got 100 records, I get 100 customer IDs. And for each record, it'll have that customer's ID, name, address, city, state, and zip. Does that make sense?
Yeah.
Because that's what this is all about. This, what you see on your screen right here, is also known as what's referred to as a database schema. And a schema is going to tell us the names, and it's also going to tell us, like we've got here, the types that we're working with, etc. All right. Now, I'm going to jump back for just a second. All right, you've seen all this stuff. I'm going to get rid of this for now. Okay. And I want to bring in two more terms. One is DML and one is DDL. DML stands for Data Manipulation Language. In fact, I'm going to do them in the other order. You'll see why in just a second. So a DDL, which we'll do first, is Data Definition Language. And that's how we define our schema for our database. All right, data DML is data manipulation language. And that's how we define the data for our database. DDL has got three different types of commands. It's got to create when you want to make something. It's got alter when you want to change something. And it's got drop when you want to get rid of something. All right. On the other hand, DML has got select when you just want to see something, not change it. Update, let's do it. Insert when you want to add something. Update when you want to change something. And delete when you want to get rid of something. So what I'm starting to show you, all right, in our schema, when we want to create the schema, we have to use either create or alter or drop. If we don't have any schema at all, we want to use create. And we have to tell the system what do we want to create. So if I want to make a brand new table, for example, I have to say create table and then give it a name, like students. Then I can start giving it information to put in. If I have a table named students and I decide I forgot to put in this field. Let's say I forgot to put in the cell phone field. Then I can do an alter table students and add that field. Then if I decide I don't need the table anymore, I can say drop. Does that make sense?
Yeah.
All right. So now I come in here and I've created this student table. And I want the first name and the last name and let's just say the address, just those three things of every student that's in my table. I got my 10-minute warning, so hold on. Come on. There. So now I've got my table. So I come in here and I say, okay, select first name, last name, address, and you don't have to put it over multiple lines, but I like to do it like this so you can see exactly what you're doing from students. Does it make sense to you what I'm getting back?
Yeah.
Okay, so now I come in here and I say, yeah, but you know what? I only want the students, I want to see how many students who are going to Rankin Technical College, Wentzville, live in Wentzville. So I'm going to say where city equals Wentzville. All right, so now this is called basically a where clause, because now instead of this may have given me just this in gray may have given me 500 records, but putting the where clause on there, now I may have knocked it down to 100. All right, as an example. So this is the kind of thing that we're going to be doing. That's what they're mentioning in here. I'm not going to say any more about this one. All right, so using SQL again to work with the database, this is the kind of stuff that we're going to be doing. Every word that you see here that's bolded is a keyword. Select is a keyword, from is a keyword, where is a keyword, order by is a keyword, and ASC for ascending or DESC for descending, those are keywords. All right. So what they do next is they start to talk about how to grab information from two different tables. All right. I'm not going to have enough time to do this now. Literally give me about 3 minutes, if you would, and I'm going to ask you guys to drop off, and I'm going to generate a new URL, and then I'm going to come back. So come back if you would in about 3 minutes, okay?